Good evening, sir. I am Sai Balaji from ECB section, and my roll number is 2341A0498. Today, my topic is amplitude shift keying from analog and digital communication, and the subject code is 23CU403. Amplitude shift keying, commonly known as ASK, under coherent detection, under working principle, waveform analysis, and applications. Introduction to amplitude shift keying. Amplitude shift keying is a form of digital modulation that conveys data by varying the amplitude of the carrier wave. It is one of the simplest forms of modulation often used in low frequency applications. ASK is primarily utilized in applications such as RFID and remote keyless systems. ASK, a sinusoidal carrier, is created on and off by the binary sequence to be transmitted. The message signal M of t is unipolar N or Z, such that M of t equal to 0 for logic 0, M of t equal to 1 for logic 1, 0 less than or equal to t less than or equal to t. Basics of coherent detection. Coherent detection is a technique used to demonstrate demodulate signals in which both the phase and frequency of carrier wave are known. This method improves the signal-to-noise ratio, enhancing the receiver's ability to accurately interpret the transmitted data. Coherent detection is commonly used in digital communication systems, including ASK. Working principle of ASK. In ASK, the presence of a signal represents a binary 1, while the absence of the signal represents a binary 0. The amplitude of the carrier wave fluctuates between two levels, corresponding to the binary data being transmitted. This modulation method allows for straightforward implementation in various communication systems. Mathematical representation of ASK. The ASK signal can be represented mathematically as S of t equal to AM, cos of 2 pi FCT for binary 1 and S of t equal to 0 for binary 0. Here AM represents the amplitude of the carrier wave and the FC denotes the carrier frequency. A plane electromagnetic wave traveling in the x direction is of the form P of x comma t equal to U naught cos of kx minus omega t plus pi. V of x comma t equal to V max cos kx minus omega t plus pi. In the EM wave, E is the electric field vector and V is the magnetic field vector. Maxwell gave a basic idea of EM waves while H experimentally confirmed the existence of EM waves. Waveform analysis of ASK. The waveform of ASK signal consists of a series of pulses where the amplitude corresponds to the bit value being transmitted. The time duration of ones and zeros is crucial for correctly interpreting the signal at the receiver end. Analyzing the waveform reveals insights into the timing and potential errors in the transmission. Benefits of coherent detection in ASK. Coherent detection enhances the performance of ASK by allowing for phase synchronization, which is vital for accurate demodulation. This technique reduces the impact of noise, making it suitable for environments with high interference. The use of coherent detection facilitates better error performance compared to non-coherent methods. Challenges in ASK modulation. One of the primary challenges of ASK is susceptibility to noise, especially in environments with significant EM interference. The amplitude variations can be difficult to distinguish, leading to potential errors in data interpretation. Proper design and filtering techniques are essential to mitigate these challenges. Applications of ASK. ASK is widely used in applications such as RFID systems, where low data rates and simple implementations are advantageous. It is also utilized in optical communication systems, particularly in free-space optical communication. Other applications include remote control systems and telemetry where energy efficiency is critical. Comparison with other modulation techniques. Compared to frequency shift keying and phase shift keying, ASK is the simpler but robust against noise, while FSK and PSK offer better performance in noisy environments. Understanding the trade-offs between these modulation techniques is essential for selecting the appropriate one of the specific applications. Conclusion: ASK-T remains a fundamental technique in digital communications, especially for low complexity applications. Ongoing research is focused on improving its performance, noisy environments, and integrating it with advanced techniques. Future developments may include hybrid modulation schemes that combine ASK with other methods to enhance efficiency and reliability. Thank you.